This week's chemical of the week is dopamine, and to look at dopamine from a chemical and a structural standpoint, you will see that it has a benzene ring connected to two OH groups on adjacent carbons. Then there is a little carbon tail connected to a primary amine group. Now, despite dopamine's complex biological functions, it is a surprisingly simple molecule, and it is closely related to other neurotransmitters that can even be considered hormones in some cases. Adrenaline, also known as epinephrine, has an OH group off of the carbon before the amine group, and it also is a secondary amine, and it has a methyl group off of the nitrogen where another hydrogen would be. Another neurotransmitter, norepinephrine, doesn't have this little methyl group and still has a primary amine, but also still does have the OH group off of the carbon before the amine. And while these are such structural, subtle differences, they make the molecule act completely differently inside of the body. If you think of how dopamine receptors, adrenaline receptors, and norepinephrine receptors would all work, they all function off of hydrogen bonding. Hydrogen bonding is where a hydrogen that is connected to an electronegative atom, nitrogen, oxygen, or fluorine, will sort of try to physically bond with another electronegative atom on another molecule, nitrogen, oxygen, or fluorine, and that creates a pretty strong intermolecular force, which is 1/10 the strength of a covalent bond. That is the definition of hydrogen bonding, and it is probably the thing that is used inside of a lot of cell receptors and dopamine receptors, adrenaline receptors, and you'll see that this simple molecule has a few differences with the amount of electronegative atoms inside of its structure. The two OH groups off of the benzene ring stay constant, and that will act the exact same on the receptors. However, in dopamine's case, it just has the amine group, and that will have two hydrogens attached to it. The nitrogen is able to accept one hydrogen bond because it has one lone pair, but it has two hydrogens bonded to itself already, and these hydrogens can hydrogen bond potentially to two other things. Now, while these molecules may not hydrogen bond in the receptor to everything that they possibly could do, it's still an interesting thing to know about the differences between the hydrogen bonding in these molecules, which could be the differences between why they have such different functions and can fit into different receptors. And the OH group, that's kind of simple. On dopamine, there is no OH group on the tail, but in adrenaline and norepinephrine, there is. Now, some of adrenaline's and norepinephrine's functions inside of the body are often to do with stress response and stuff like that, and norepinephrine can have things to do with arousal response and cognitive functions as well. Dopamine doesn't really have anything to do with stress at all, and these two molecules, which have the OH group on the tail, do. So maybe something to do with how this OH group bonds with other receptors could potentially be the thing that has something to do with stress. Looking at the differences between the two molecules and the differences between their two functions, this could be potentially quite a logical conclusion to make. I can't back that up with anything, but that's just an interesting observation that I can make off the top of my head between these two molecules. Now, in terms of dopamine's biological functions in the body, it is responsible for reward cycles, motivation, drive, satisfaction, pleasure, and all that sort of stuff. There is responsibilities, and dopamine deficiency actually has an interesting sort of mechanism to play. Now, many influencers talk about dopamine detox and getting rid of dopamine from your systems and stuff like that. That is completely incorrect. Dopamine deficiency is a really bad thing. You want to have a high baseline dopamine because that equals high drive, high motivation, and high satisfaction. Also high pleasure as well, but I think differentiating between pleasure and satisfaction is a bit of a weird thing inside of the body. Long-term pleasure is like where you constantly feel good and satisfied and happy with your life. When you have dopamine spikes, that is a bad thing because it means that it has spiked, it has peaked, but if it is a spike, that physically means that it must have gone down again, and that's not what you want. You want your dopamine to be consistently high. That's the key here. Dopamine detox is a bad phrase to use as much as its purpose and its whole sort of the thing it's actually trying to sort of promote and get behind is completely correct. It's a completely incorrect phrase to use. You want to increase your dopamine using delayed gratification, like literally simple things: reading, meditating, working out, things that do not take up as much time as you may think, things that do not take up as much energy, do not actually take that much hard work at all. But if you just keep consistent, and that's the main thing, you will see results and you will have this higher baseline dopamine, which literally makes you happier. You will feel more satisfied with your life. You will feel pleasurable 100% of the time, which can seem quite weird to say that, But eventually you'll get to a point where your baseline dopamine is higher than some of the spikes you would get from degenerate activities. If you imagine the high some people feel from doing drugs, going to parties and drinking weed, etc., etc., if you imagine the high that they feel from that, that actually could be lower than a happy person's baseline dopamine levels, and they have no reason to do that stuff because it doesn't actually make them any happier than if they were just living their own happy existence, working hard, just having fun. Essentially, that is what a happy person's life inside of their brain chemistry is like. And so if you do essentially imagine the sort of the graph of dopamine, when you do bad habits and degenerate activities, the dopamine will spike because you feel a high in a way, and then when it dips again, it actually returns to below the original baseline, and so you crave more dopamine. You crave the dopamine that sort of exists because that is where happiness can be achieved. Your body wants that happiness, so you will achieve it in the shortest amount of time possible. That's what your body wants. As much as it's kind of like a crux, it's a bad thing to have that urge. It's a natural response for your body, but because we have so many things available to us where we can just instantly get pleasure and satisfaction. However, in tribal times, we couldn't just instantly get pleasure and satisfaction. We'd have to build social connections. We'd have to go out hunting for food. And there was really no way to actually have any sort of instant gratification, which seems kind of weird, right? But in society, that is how life works a lot of the time. And so you have that sort of the porn, the drugs just at your disposal, which is, yeah, it's quite a weird and unnatural things for humans to have. Now, another interesting thing I learned about dopamine is that it isn't actually responsible for the pleasurable sensations, but more rather the urges that you get to do these activities, do these bad habits. That is what dopamine is responsible for. That is what dopamine's sort of crux is when it's low and when your baseline is low. And then obviously it will still rise when you do the bad habits, but that's not the reason that you feel pleasure. That's to do with things like serotonin, other neurotransmitters, maybe it's, I don't know, norepinephrine, loads of random stuff. But the sensation when you have the urge to do something is normally because your dopamine is lower than the dopamine you would get from a spike from that activity. But if your dopamine baseline is higher than the spike you'd get from that activity, you have no reason to do it, and your brain is like fine. And I recommend subscribing for more content like this, and have a good day.